What are variance and standard deviation? In this video, we will try to understand that. Let's say we are given some data and we want to know how distant the data is from the central tendency. In other words, we want to know the extent to which the data is scattered while comparing it to the mean. We use variance and standard deviation for that purpose. Data that has more variance and standard deviation is more scattered while comparing it to the central tendency or the mean. For example, this blue plot shows a normal distribution with a mean of 0 and a standard deviation of 1. This orange plot shows a normal distribution with a mean of 0 and a standard deviation of 2. And this green plot shows a normal distribution with a mean of 0 and a standard deviation of 3. As we can see, when we increase the standard deviation, the numbers are more scattered from the mean 0. How to calculate the variance and standard deviation? Let's understand that with an example. Let's say we roll a fair die once. As the die is fair, all the numbers 1, 2, 3, 4, 5 and 6 are equally likely. In other words, P1 is equal to P2 is equal to P3 is equal to P4 is equal to P5 is equal to P6 is equal to 1 by 6. Suppose x is a discrete random variable that denotes the outcome after rolling the die. So, expectation x is equal to weighted average of all possible outcomes, and after calculation, this is 3.5. This expectation x or the weighted average of all possible outcomes is called the mean, and we often denote this mean as mu. So, if we want to calculate how far x is from the mean mu, we need to calculate expectation of absolute value of x minus mu. But calculating expectation of absolute value of x minus mu is mathematically inconvenient. So, we calculate expectation of x minus mu whole square and we call this the variance of x. So, the variance of x is equal to expectation of x minus mu whole square, and after calculation this is expectation x square minus expectation x whole square. And we define the standard deviation of x as sigma is equal to root over of variance of x. So, in our case, the variance of rolling a single fair die is variance of x is equal to expectation x square minus expectation x whole square, and after calculation this is 35 by 12. And the standard deviation of rolling the die is sigma is equal to root over of 35 by 12, and after calculation it is 1.7. Now let's say we are given n numbers and we want to calculate the variance and the standard deviation of the numbers. We can calculate the variance of n numbers by using the formula sigma square is equal to summation over I xi minus x bar whole square divided by n, where x bar is equal to mean is equal to summation over I xi by n, and the standard deviation sigma is root over of variance, that is root over of summation over I xi minus x bar whole square divided by n. Please note that the variance we calculate using this formula is the true variance. If we want to calculate the sample variance of a sample and use the sample variance to infer about the variance of the population, then we need to use n minus 1 in the denominator instead of n. In other words, the sample variance of a sample is sigma square is equal to summation over I xi minus x bar whole square divided by n minus 1, where x bar is equal to mean is equal to summation over I xi by n, and the sample standard deviation of a sample is root over of summation over I xi minus x bar whole square divided by n minus 1. Let's look at an example. Let's say we are given 5 numbers. We want to calculate the variance and the standard deviation of the given numbers. So, as per the formulae, x bar is equal to mean is equal to summation over I xi by n, and after calculation this is 5. Therefore, the variance sigma square is equal to summation over I xi minus x bar whole square divided by n, and after calculation this is 9.2, and the standard deviation sigma is equal to root over of variance, and after calculation this is 3.033. I hope this helps. Interested viewers who want to know more, please refer to the playlist Statistics for Machine Learning or visit the website of the Security Buddy. You may also want to subscribe to us and get notifications on recent videos.